Well, welcome everyone to Desmos Creation Station. You are in for a treat today with what Andy and Tom have prepared. Just a couple reminders, please use your first and last name, just like a name tag, so you can rename yourself if accordingly. If you have any tech issues throughout the session here, please private chat me and I will see what I can do to help. And then at the bottom of the screen, as you've seen all day with the unmute and the stop and start video, if we could just keep both of those off for now, that would be awesome. And make sure to keep your chat open so that you see things as they come up. And there are subtitles available, and you can find that at the bottom of your toolbar. So with that, I will turn it over to Andy and Tom.
So welcome everybody. My name's Andy. I am a co-creator of this along with Tom Kroeger, and I'll let Tom introduce himself.
Yeah, I'm Tom Kroeger. I'm with Roseville Learning Center in Roseville, Minnesota. And hey, Andy and I are kind of excited to talk to you today about how to build a Desmos activity.
So some of you have used Desmos in the past and maybe picked up some activities. This one, we're going to focus a little bit more on how do you create your own. So our main objective today is to learn some how-tos about Desmos activity creation. We're going to share with you a lesson that we created and how we did it. And this was really a learning position for us too. We jumped into this both feet and learned stuff as we went. So we're going to talk about some of those. Realize that some of the functions in Desmos can be confusing, but the best thing is just get in and start working with it. We'll share with you some tutorial videos on how to do this in your own time. So Tom, if you want to take this one.
Yeah, so basically just kind of give a background into the research of why technology is so important. Obviously, a lot of us are distance teaching right now, and there's so many technological tools available to us. And some of the current research is related to this TPACK framework. Some of you may be familiar with this. In the slides, you all have should eventually have access to the slides. There are links here to a YouTube video as well as 2 articles written by Mishra and Kohler about how when they came up with this TPACK. And basically what it is saying is, along with your content knowledge that you're experts in and your pedagogical knowledge, also combined with that is your knowledge of technology and how you can use technology, not just as a supplement, not just something to help teach a lesson, but actually use it for your students' learning. There's a lot of different examples that are out there on it. And so Desmos has just had to be one of those pieces of technology that a lot of people are using right now. So this slide is just kind of give you access to some of that research and a little bit of information about where this is coming from. Move to the next one. And then Desmos itself, Dan Meyer, one of the Desmos gurus, wrote an article back in September about Desmosifying your lessons. And they came up with these four elements of what they call Desmosification. One is a Desmos activity includes what's called progressive disclosure, which gives students a concrete experience before giving them the abstract. Right? So starting with something that they can attach to and then moving towards the abstract. The second one is connecting the concrete and abstract representations. So if you see the animated picture on there of the robot and you're moving the point, so there's just this abstract point that you're moving around on the coordinate plane and how it changes the height of the robot as well as the distance between the eyes. I know it might be kind of hard to see on a smaller screen, but this is all linked in that article, which you can click on the title there on the top. Interpretive feedback versus evaluative feedback. Students are able to get feedback in multiple ways. And the final thing, which is probably the most important thing, is students are allowed to express their creativity and make their own connections. And a lot of times when teaching math, it's like, here's the answer, here's what you're supposed to be thinking in this way. But with if your lesson is Desmosified, as Dan Meyer points out, then students can make their own connections there with their activities. So,
right. So the options we can think about when we're jumping into Desmos, and if you just go straight to Desmos, we've got the general tools that are involved there, just graphing calculator, the 4-function calculator, the geometry tool. go to desmos.com. You've got access to all of these where you can just get in and use them or play with them or have your students look at them. But if we switch over and instead go to teacher.desmos.com, we now, instead of just having the general blank page for us to work with, we now have some activities that we can use. And as has been stated earlier on some of the earlier presentations, there are activities that are all pre-built. You can just go in there, grab one, go in, use it in your class, but you can also custom create your own. And then the other thing that we can look at is they have a web address of learn.desmos.com. And that's kind of the tutorial for us as teachers. Like, what do you want to learn? How do you use the graphing calculator, or that middle one with the magic wand? Like, how do you create your own activity? So if you're getting in and starting to try and work your way through things and you go, I don't know how to do this, jump in and take a look at one of their lessons. How do I create this? How do I add this particular thing? So don't forget the teacher.desmos.com and learn.desmos.com. So for today, we're going to play with some slides in student mode in an activity that Tom and I created. And we're going to talk about how the teacher moves work within that system. You are going to be toggling between the two windows, so make sure that you kind of maximize your Zoom window so you can have the two windows next to each other. That'll be a lot easier for us to kind of toggle back and forth between them. If not, you can just switch on the bottom of your screen and switch between them. That's okay too. Feel free to try all the questions on your own, but we'll be bringing everyone back to Zoom to show you some necessary functions on these. And then we're going to take a look kind of the behind the scenes, welcome to the Wizard of Oz type of thing. What do you see on the back end of the activity or the creation side besides the student side? So we're going to go to our activity, and Tom is going to lead this one. And Lindsay has chatted in the link, so please go to that student.desmos.com, and then there is the code that we want you to enter.
Okay. Yeah, so once you go to that website, you'll have the option of signing in, creating a Desmos account if you don't already have one. You don't have to, but if Desmos is something you see yourself using in the future, you may want to just create an account. It's very simple with Google, especially if you've got a Google account. Or you can just continue without signing in. And let's see, as people start coming in here. Andy, do you think we should switch over to the teacher view so people can see what happens as they sign in?
Yes, you can go ahead and take over the screen.
I will switch sharing here. Let's see. All right. So as people are signing in, I see we've got a big group of people today. So this is, as a teacher, you would see this. This is not what students will see. On your own screen, you're seeing the 4 slides. You're seeing the splash screen, that first one. And then, but on the teacher side, if you're looking at the Zoom screen right now, what you'll see is all these names populating a list here. And right now, I have everybody anonymized. So all the names on here are actually, Desmos is kind of cute. What it does is it'll actually, if you don't want your students to see each other's names, you can kind of make it anonymous. But instead of saying student 1, student 2, student 3, and so on, it actually names them as famous mathematicians throughout history. So if you turn off the anonymize, it'll actually show the students' names and based on what they entered. But in this case, I'm going to keep everybody anonymous so that I think you know who you are. It might show who you are, but as far as the group, when you're displaying the group, it only shows these famous mathematicians. So
okay.
Yeah.
And do you want to lock the pacing into just to slide 1 and 2? We already have some people in slide 2, and that's fantastic.
I can lock. Yep. So the nice thing is that you can pace the students. You can say, hey, I don't want you to go any farther than just these couple slides. So I can turn off I can turn off slide 3 and 4 and wait for everybody to get to a certain point before we let them go. So just like you would in a normal lesson, you pace yourself through.
So notice any of you that are in the activity as a student, if you're on slide 1, the next is highlighted, so you can go to the next slide. If you go to slide 2, the next is grayed out. So I can't go to slide 3 right yet until we finish slide 2.
Let's see.
So go ahead and try that problem in slide 2.
And so then on the teacher side of it, as you're putting in your answers, the teacher, which I'm showing on the Zoom screen right now, the teacher can actually see what each student is putting in. And again, it's anonymized. So I see that you're all famous mathematicians. But you can see a variety of responses, which allows you can highlight some from particular students if there's a response that you want to point out to your group, or make a note about or ask questions about, as students are even changing. It's virtually live. So as you are adjusting your points, and maybe I see some people using the line tool, changing colors, that happens all live as you're doing it. The teacher can see things.
Hello, Ruth. Whoever Ruth is, you're drawing a nice picture smiley on there.
So that's Ruth. Yeah, Ruth Gonzalez. Yes, he's again. Mary Jackson is on there. Joseph Fourier.
Yep.
So Blaise Pascal. Yeah. So I kind of from an equity standpoint, it's kind of interesting because you can introduce your students to some of these people who they may have never even heard of. So.
And so if you notice, this is a problem we literally just pulled right off of the GED item test practice, and then just added this section in.
Right from GED.com, right, Andy? Is that,
yep.
From yeah.
GED.com, the test practice, not the GED readies. So as a teacher, if you notice on Tom's slide there, you can scroll down through and see if somebody's really kind of not seeming to get it. And for the most part, looks like we're doing pretty good.
Yep. Some people are having fun with the dots, and
yeah,
that's
Gauss is really having fun with dots. Okay, so, and it seems like everybody's got a pretty good idea on how the pencil works. Realize you can also do the line, and some people are doing the line. And of course, if you make a mistake, you can go over to the eraser and erase. So are we open to 3 now?
I can open. Okay, so now you should be able to proceed to slide 3. And I can see the numbers jumping over as folks are jumping over to that slide. I can see the numbers changing. The teacher dashboard shows you how many people are on each slide.
So we still have 3 people in slide 1.
Yep.
Okay.
As the teacher, I can click on each slide, and then I can jump over to that and see as people are entering.
So if we're looking at Tom's thing, we can see that for the most part, for most people, we can't see any dots. All of a sudden, Victor Newman, we can see dots, and Evelyn Granville, we can see dots. Jacob Steiner, we can see, right? So what are we doing to be able to get to see those dots? And you can unmute and answer that question. There you go. I heard somebody unmute because I heard a lovely young child in the background. How can we get to see the dots? Someone answer that question.
So I can
Wow, we got
highlight.
shy people today. Go ahead.
I was going to say that. So as you're looking at the group, you can click on one particular student, and it'll blow that up, and you can, if you wanted to, you could display that to your group on, if you're in person on a board or share it on your Zoom screen like I'm doing with you right now.
Right.
I don't believe as the teacher you can make any adjustments. Oh, yes, you can. Look at that. I can grab it and I can move it. I'm learning something right now. Look at that. I can move the students' work around. How about that? I didn't know I could do that. I'm just learning that now. So.
Okay. And
I don't
so
know if that
Adrian
changes the student screen.
just put in some numbers. Remember, we were going to put in the numbers for the tree 2 into our table.
Right. And so you'll notice that when you change your screen size, that it does change your it changes the picture too. It'll adjust the picture because the picture is locked to the grid.
Okay, so we put in there the table for people to be able to put the numbers into, and notice that we had the X1 part of the table pre-built, right? Those were all entered in by us previous. And then we asked to put in the points for 3, 11, and 13. Now, if somebody puts in the points for the other points, that's absolutely fine. They still work. There's no problem there. But as you do that, and I don't know, Tom, can you tell? Oh, I'm Herman Grassman.
Oh, you're Herman Grassman? Okay.
I'm Herman Grassman.
Okay.
So if Tom's showing mine on Herman Grassman, you can see that I can't see my dots, but if I just grab and drag, right, we can drag that around and it should reset.
Does it update mine automatically?
It's
here?
not updating yours automatically, so you should probably get off of me and then re-update.
Yep. So yeah, so it kind of freezes it. So now it updates it.
Right. So when we do that, I can drag to see those points, but we also notice that the grid lines that we have in this activity don't seem to be very well set because they're kind of more rectangles than they are, good squares. The scales may be a little bit off. And so we asked you in the instructions, use the wrench tool to adjust scales on the X and Y axes to make the points and axes visible. And that was our note for number 3. So Tom, if you want to see if someone else has gotten a good grid set.
Yeah. Now, Andy, let me ask you, because since I have yours open,
yes,
the changes that I'm making, does that show up on yours?
It does not.
It does not. So any changes I'm making here, like shifting things around in Zoom Square,
right.
in the Zoom Square, okay, that's only on my view. Okay.
Yeah. So what it did is it took a picture of my student screen at the time that Tom said, look at Herman Grassman. And it took a picture of that, and then Tom can play around with it on there, but it does not change the screen of the actual student.
Okay. Yep.
So I'm going to go ahead and change my graph settings, but see if you can find someone who has a good graph setting. And what do we see?
Let's see. Got Adrian, Scott, Dwayne. Looking here. These small screens are kind of hard to see without looking at blowing them up here. Jakob Steiner, that one's not so bad. Jakob Steiner's got. So.
Okay.
So yeah, so now right now I have Jakob Steiner is up on here, and that one looks like it's adjusted a little bit more.
Right, and we can see that we've got a good axis on both of them. So he went to some negative values for X and Y, but got the points in there where they can be seen.
Right. Yeah, this little wrench tool is a neat deal. You can.
Right.
Yeah.
And notice on the wrench tool that Tom has open on his right now, that you have the ability to change the X axes and the Y axes, and we have the labels listed in there for year and tree 2 diameter. But right above the X axis, there's a little thing that says Zoom Square. Yes, right there. So if if the scales don't look right, like we're getting these rectangle-y looking things because our X and Y scales are not squared up, whatever scale you put in, so if you put in values for X and then hit zoom square, it will adjust Y so that on the screen, everything is squared off. If you put in the values for Y and then hit zoom square, it'll adjust the X values to make it work.
Right, because sometimes when you put in them, depending on the width of your actual screen, because a lot of us have wide screen, whether it's a tablet or a computer screen, it's wide screen, so that you may think you want to go 10, negative 10 to 10 and negative 10 to 10 for your Y, but that may be stretched out on your widescreen monitor, and so the zoom square will force everything to be nice square shaped. But then it'll change either your Y or your X, the range of your Y or the domain of your X on your grid there. So
and so when we
details like that, yep.
Yeah, and when we created this, we made those scales kind of not very useful to the problem that we're doing on purpose to try and make sure that the participants have to learn how to adjust the scales. Because part of what we're doing here is to learn the process of using Desmos, not to learn the answer to the actual problem.
Right. Yeah, we're just using this GED question as our sample. This is our example to play with today.
Right.
Yep. Desmos can be used for lots of different things, and surprisingly, not only math. There are other things that Desmos can be used for that are outside of math. And there are, if when you have a chance, you can search through the library of activities that they have, and you can get some ideas about other activities that are essentially maybe not math related. So we're just using a GED question here for the sake of this.
Let's go ahead and open slide 4.
Okay, slide 4 is now open, and this is the final slide. So there's only 4 slides altogether.
Everybody can go over to slide 4.
Jump over there.
Okay. So we're going to create a line that passes through the given points by using sliders. So we wanted to add this one in to show you how the sliders work. So as you go through there, just play around with dragging the sliders for X1 and Y1. And then if anybody else has a different way to adjust things, and tell us what is happening on the screen as you're adjusting those sliders. And you can unmute and talk about that.
It's moving the point.
Okay, so we're moving the point. Okay, so anybody notice anything about moving the point? Any problems or any issues we're having right now?
It doesn't move far enough for the Y.
Okay, so how could we change that?
I just clicked on the 10 at the end and it let me move it to 20.
Right, so if you look at the note number 4 on there, it says click on the 10 on the sliders for X1 and Y1 to adjust their bounds and be able to reach the points, because right now they won't. Also notice in X1, if you click on that, you're able to adjust the bounds for where X1 will go. We can take a look at that and say, you know what is reasonable, right? We know this is not, nothing's in the negatives. So I don't need to have X1 going all the way down to -10. But also look next to it at the step. Okay, is anybody noticing anything that's different in the step for the X1 and the step for the Y1?
One is whole and one is tenths.
Right. Why would we have done that? Why do you think we set it up that way?
It'd be too stretched.
Okay. Notice that the X values in our tables, like she's saying, it'd be too stretched. Our X values in the tables are all good whole numbers. Those are our years, right? There is no decimals in there. But in the Y values, the trunk diameter, we do have tenths. Okay. So is Tom, do you want to show the thing? Says, oh, good. Who's Gauss? Who's doing that with Gauss? Because that's awesome. You're doing something just perfect there.
So I'm showing Gauss right now.
Right.
From the teacher view. I don't know who Gauss is, but I've been manipulating this myself.
Oh,
just kind
you're
playing
manipulating
with
it. Okay.
Yeah, I'm the one manipulating it right now. If I exit out, it'll reset it, and we can see what Gauss is actually doing. Let's see.
And you can go ahead and grab mine again, Grassman.
Okay.
And we can show.
Okay.
Show mine.
Herman Grassman. Okay. So yep. So Herman Grassman is okay. Andy's.
So I might have you regraph that because I'm gonna readjust mine here.
All right. I'll go back to Gauss because Gauss had made some changes already, I think.
Okay,
so,
perfect.
So looks like Gauss has changed the range on the X and the range on the Y from 0 to 20.
Good.
That would encompass all the amounts that we need. Yep.
Okay. And then again, it's taking just a picture, so we can't see it in real time as the student is adjusting it. So Tom, if you adjust that, can you show either on mine or on Gauss, whoever was there, the fact that I saw what you were doing earlier? Not only can you adjust the sliders, but you can go ahead and grab a hold of the point.
Oh yeah, yep.
And adjust the point as well.
Yep. As long as your sliders are set to where you need them, you can grab the point and drag it up as high as you need to, or anywhere you want, within the restrictions or the constraints of what you set for X1 and Y1.
Okay.
So like I can't, like Andy has set X1 down to 0. I can't drag the point any farther down than X equals 0. So
right.
10 and 0, 10, the point 0, 10 is as far down and to the left as I can drag that point, because that's what he set for his constraints.
That's my minimums.
Yeah.
Okay. Want to go back to the teacher view, see if anybody followed the instructions for number 5. Looks like we got a few people that did.
Some lines going on here.
Mm-hmm. Okay. So we created that equation for the line, the y minus y1 equals m times x minus x1, to give a point slope form of an equation. X1, y1 were already set, right? So we don't have to worry about those. Those were done from our slider before, but you can adjust the slope by adjusting the slider for m. But notice that when we did this, there was no line. But if you click on the little dot in note 6 or in the section 6, it turns the line on.
Right. So you can just select it and it turns it on and off. Right. And you can actually, if you long press on it, if you click and hold, you can actually change from solid to dashed or dotted. You can change the color between these different six different colors. So there's some options as far as, things like that, some style choices.
So, that's something you can do with your students to kind of have things pre-built, but not have them focusing on, oh, there's a line there. And as I move it, I see a line moving, that they don't see that line until it's time for us to talk about the line. And then for the one that you have up here, notice that we can also click on the intersection between the line and the y-axis, and it will automatically tell us what that intersection point is.
Right.
So even though we've set up the equation in point slope form, we can then find off of this graph what the y-intercept is to help the students understand how do we do that manipulation to change from point slope form to slope intercept form.
Right.
Okay. Any questions over this activity?
I was just going to add, Andy. Yeah, I was just going to add, Andy. Again, if you're not teaching algebra, this is just an example we're using to show you what Desmos can do.
Right.
With an algebra type question, if you're teaching other areas of math besides algebra, there are other applications, and this is just the one activity we each happen to choose.
Caroline asked about where to make the line appear. It's that circle to the left of the equation, y minus y1 equals m.
Right.
You should see that's in like access 6 or section 6.
Line 6, whatever. Yeah.
and then, yeah, right by the 6, you see an empty circle. If you click that, you're going to get the line. If you click and long hold on it, then it will give you the option of changing your color or changing your style of line and stuff like that. So you can turn those on and off.
Right. Yeah. If you look at your Zoom screen, I'm showing that right now. So
Okay.
Clicking it on and off.
And we're going to take everybody in and kind of show them how all this works. But I want you to notice right here on slide 4, everybody pay attention to what is the very first thing in that left-hand section there. So the item 1 is our note that says adjust sliders X1 and Y1, right? That's what you as a student see.
Yep.
Okay.
That's the task. That's the task for the question.
Task.
Yep.
There's just one more question about what is the arrow to the left of the options?
Go ahead and click that. See what happens. We'll tell you, but it's fun to play with it and see what happens. Okay, so whoever asked that, when you click it, what do you notice?
So I'm showing on the Zoom screen right now what happens when you click that little arrow.
Right, that things start to automatically adjust. Why don't you set it up to only adjust one at a time? It's getting kind of confusing.
Yeah. So I'll just do the slope. I'll just change the
Right.
slope. And
Okay.
let me move the point back up here. Best I can. There we go.
There you go. So you can see how the slope kind of runs through a slide on that slider from its maximum to its minimum. You can also see the 2 little arrows that are right underneath the play or the pause button allow you to adjust how fast that changing is occurring and whether it rotates back or starts at the beginning and then goes.
Right.
Right.
And you
So
can adjust speed as well. And so
right.
yeah. Just one of those, cute feature that
So it's
if you
it's a
wanted to show
nice
something
thing
animated.
for, if we're talking about slope and you can show, okay, this is what a positive slope looks like. This is what a negative slope looks like. This is a 0 slope. And those types of things, just to let the slider play it and have the students go, wow, what's really going on here?
Right. So,
okay. Any other questions about the activity that we've gone through so far? Okay, so I'm going to go ahead and take back the screen sharing.
okay.
Okay, so you should be here. Dun, 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 go. I can see it on my computer. I don't know why I'm not seeing it on everybody else's computer.
I see.
Oh, because I'm looking at my thing, not that one. Okay, there we are. So when we're seeing that activity, then we're going to go and look at how did we create this activity. Okay,
Right.
so
if
for
everybody
right
can come back to
now,
Zoom.
do not go to teacher.desmos.com. We want you to stay here on the slides and kind of follow along with us. And then we can go to that a little bit later and play with it. But if you go to it, we're going to have, 50 people in 50 different spots. So when you first type in teacher.desmos.com and click it, this is likely what you're going to see. So you can see over there on the left that it's got some popular activities, featured collections with conics and exponential functions and linear functions and all kinds of stuff over there, right? It's got a video to help you kind of see how Desmos activities work. But we're going to focus in over here on either create an account or with sign in. So if you've already created an account, then you would sign in. And if you haven't, go ahead and create one. It's completely free, so there's no problem in doing it. So this is my teacher.desmos. You can see that I am logged in up there. So it's got the Andy Albee. And it says get started with your Desmos classes, and then the featured connections with the starter screens and the middle school geometry. So if you're saying, I just want to try and get some geometry stuff, let me click in there and see what happens. But for us today, we're going to focus in on, you can manage your classes, have a history for any activities you've gone through in the past. You can look at collections that are already created. but we're going to focus right here today. We're going to focus on making a custom one. So we clicked on custom and it opens up this screen. This is our custom activity screen. And this is one that I took a screenshot of this prior to our full creation on this, because we started this as a level E standard and then said, you know what, we're going to back out and just look at the creation of it. So we can look right here and we clicked new activity. Okay, so if we want to start something brand new, just click that new activity and boom, you're starting up. And the very first thing it's going to do is ask you, give this thing some sort of a title. And then you can choose whether you're going to have a link to this that other people can go to, or right now is just mine, right? If you go to the private, then you can play around in this and work with it and no one else can see it. If you go to the link, then the people can only see it if you give them the link. And it's always nice to throw in an activity description, just kind of remind yourself and others what this might be doing. Okay, so we give the activity title, and then we start in here. So with a brand new activity, you'll see I just named this activity blank when we started it. So there's our title right up at the top. We've got one panel available. Those panels in Desmos are called a screen. Okay. So we have one screen that's available, and we can see right next to that screen, there's a little plus with a circle. So that's what we want to use. We want to add more screens. And when we look down this left side, you can see that there are activities that you can add into your screen. So it says, choose an item on the left to add it to this screen. So there's our screen with our add new screen. Oh, that got offset. Okay. That's supposed to be around the activities on the left-hand side. And there we just blew them up so you can see them easier. Notice there's be able to put in notes, be able to put in math inputs, ordered lists, graphs, sketches, graphing calculator. So we'll take a look at what some of these buttons do as we go through. So here are the 4 slides that we just went through as students. And so we're just going to go through and talk about each slide where what we did. So we did an insert media. We took a snip of the GD question, and you have to save it off. You can't do a copy paste in Desmos. It doesn't work that way. So you're going to have a picture that you have saved as a file and then upload it into Desmos. And then we inserted the note in slide 1 just to remind or tell the students that this is a question from the GD math test preview. You've probably seen it. So in slide 2, we went through, inserted a media again. Now this one, we took just the information part of the activity from the GD test preview. And then we inserted a sketch. So a sketch is a graph set, but it's the one where you get that little pencil drawing and that line tool that the students can go in and just try to find a point without actually entering in data. So that's where they do that sketch part. And you need to edit your axes and things, especially if you want to add a title to it, so that the students see what it is you want them to see. In slide 3, we want to enter a graphing calculator. Notice when we enter the graphing calculator, that is a full screen activity. So you cannot add in like the media picture and then the graphing calculator. It's going to be just one. Okay. Then we clicked the plus in that left-hand activities section, and we added a folder. Okay, now the important part of a folder is then we can put activities and things inside the folder that affect what you see on the graph, but the students don't see them. So we inserted a folder, we added the table, and we took the table and made sure that the table was outside of the folder. The image, the picture of the data table that we clipped from the GD test is inside the folder and is hidden. So the students don't see the instructions as to why that's there. It just shows up. Then we added all the X1 values into the table. And in Y1, there's the little dot with the green with the white polka dots in it. That says, if I put a point into Y1, please plot that point on the grid. For sections 3 and 4 on that list, all you have to do is hit your quotes mark, and it will automatically recognize that that is a notes. You can also click the plus and that second section down where it says note. But if you just hit the quotes, it goes automatically. And then we clicked the wrench in the upper right-hand corner of the coordinate grid graphing calculator to adjust our graph scales and titles on the axes if you want to get those set up properly. Now, it's a nice thing. We kind of describe this backwards. It's a nice thing to get your grid and your scales and everything done before you add the picture, because the picture is attached to the grid. And so if you put in the picture and then adjust the grid, the picture can get really distorted and hard to read.
Yeah, you'll notice that happen for some of you when you were adjusting your scale on your grid, that the picture also changed with that.
Okay, and then in slide 4, right up there on that left-hand side where we've got the plus, oh, thought I had that highlighted on there. There's the teacher tips, and then there's the little 3 dots on it. And we can choose to duplicate the screen. And so what that does is that just takes whatever we had in screen 3 and duplicates it in screen 4. So you don't have to recreate everything, right? Everything's already there, and then you can just adjust. So we move the table into the folder and we rename the points A and B instead of X1 and X2 because X1 and Y1, because we wanted to use X1 and Y1 as sliders. And if they're already in the table, then we can't use them as sliders because they're already defined. So we did A and B to get our 3 points on there. We typed X1, Y1 into the folder and added slides. So we added the slides for X1, Y1, and then moved the sliders outside the folder. So the fact that there is a point that is labeled as X1, Y1, which is currently at 0, 0, and that red point that we started with, the fact that that point exists, the students don't see that. They only see the sliders, but the point is actually inside the folder.
There's a lot of different options as far as like customizing, tons and tons. We went through a lot of different variations of things as we were making these and trying to decide how do we want it to display just exactly what we want for the students. So there took a lot of playing around with different things. And so, yeah, so there's lots of different features. Again, it's not just algebra related. We're focusing on algebra for this particular example. But there's a ton more stuff that you can actually do with this. So then do we want to move on and give folks a chance to kind of look at the guts of this and themselves?
So we took and typed the quote to put in the instructions, then we added in the point, and we clicked on the dot on the left side to turn the line off until we have the students turn the line on.
Yeah, and then what you had the opportunity to do is turn it on. So
correct. So we got those. Okay, so here is the activity that that we're going to work with. So you can just take that link that Gail just chatted into the chat box, go to there and see what we have. Okay. And oh boy, this is our big one.
Is this our big
one? That's the old one.
That's the old one.
Okay. So you got lots of stuff on this one.
Oh, it's a lot of empty, lot of, yeah.
Right. So sorry, that was supposed to go to a blank one.
Oh, well.
So we got the wrong link in there, but that's okay. We can still go to it. you should have the access over there to like create a copy. Okay, mine says edit draft because I was the one that originally created this. Does everybody else see a make a copy?
So if you click on, yeah. So you may have, if you haven't created an account yet, you will need to create an account to be able to copy and edit.
So our goal was to have you create a blank one, which actually you could go just click, you know, new activity and just start a blank one on your own. And there is a Google document in the participant folders, and Gail, if you could chat that one out, that has some instructions on some activities that you can do, or if you don't do the activities that we lined out to there, get in there and play around with it and try something on your own. Okay, so there's the link to the participant folder.
Yeah, I know there's some folks in the chat who are asking about different levels of activities and stuff. So yeah, you can search through their library and see if there's things that are in the area of what you're teaching. That back in the one of the earlier slides where we had that robot, that is actually from an activity talking about scatter plots. So that's something that Desmos had created, and I actually found that a while back, and before I had read the article, I didn't realize the article was actually using it as an example. When I found this, it was showing that connection between moving a point on a grid and what you adjust your X coordinate and you adjust your Y coordinate. What does that actually mean to something real, like the height of that robot and the distance of their eyes? And there's a whole activity that goes along with that. So if you're teaching something about like scatter plots, for example, that robot activity is really kind of neat. And it's very simple, very straightforward. And so there's a lot of different things that you can search for.
Am I back on? Can everybody hear me?
Yep, I hear you.
Okay, thank you. No, my computer just kicked me out. So I just jumped back in.
So the one downside is that if you're trying to search for things based on CCRS, unfortunately, there's not a lot of Common Core codes. So it's searching by a particular standard code is not going to result in a lot right now. I don't think the Desmos team is thinking about the Common Core codes as they're coding things. I haven't heard if that's something they're planning to do. So for right now, as you search for things, you just have to search by keywords. And there's tons of stuff to search through, things that other teachers have created, things that Desmos folks have created.
And I see some people in this worksheet. I really do encourage you to click on it, and I see maybe 7 or so. But I just put the direct link in the chat, and it really is broken up step by step, from creating an account and clicking on custom and new activity to giving you suggestions for how to add a page and how to add media, which is great to just get our feet wet with that. So
right, and we just went through basically with the next question from the GD math test preview, which is the one where they're supposed to take and create a slope intercept form of an equation for one of the trees. And you could see how you could take that equation or that problem and Desmosify it and have your students really get in and start adjusting things and seeing what's really happening as they adjust the slope or as they adjust the y-intercept, and does it match up with the points it's supposed to match up with. That can be a thing to not only just have it's y equals mx plus b, so I've got to do y equals mx plus b. You know, the students get stuck on formulas quite often, and they don't think about what do these formulas really mean and what happens when I adjust things. That's where Desmos is just a huge benefit to allow them to get that visual pictorial lesson.
Right. Yeah. I as a student, I remember like how much time it took to draw one graph on a piece of paper, and then you're limited with the time as far as what you can do with that. With something that's interactive like Desmos, you can get the graph very quickly, and then you can manipulate it and see if I change just a little bit, how does that how does that adjust my graph? If I add this data point, what does that do to my information? Much faster than the old pencil and paper type thing. So again, this
Right.
is just one tool among many that are out there for us to use. And like Andy and I been saying, it's like we had just started playing with it, just to kind of explore, like, what can we build? Let's take this GED question and can we turn it into a Desmos activity?
Right. And so if you look at here, like there's a card sort activity, there's a math answer box activity. And so, you know, if we had something here, we could add in a note. Let's see if it'll let me do that. Add note, there we go. So I could put in an instruction up here. Please write your equation for tree 2, right? And give some instructions into that, and then put in the math input where the student, as when they go into this, they would actually have the ability to type in their equation into there, and it gives them a lot of the symbolic things like pi and approximately and greater than and less than and greater than or equal to, less than or equal to, that you don't get on a standard keyboard. So you can have the math input materials, and you can click that box where it says, ask your student to explain their answer. So if they have to type something in, they can't just say, well, that's just the answer, right? Well, give me more than that. Describe it and help the other students to understand what your thinking was.
Right. And like, and you can find ways of using these same types of activities for non-math questions
Yes.
too. Yeah, you don't necessarily have to be a math question. It could be, it could be like, how are you guys feeling today? Kind of thing, just to check in, or an exit ticket, for example, or something.
For any of you that were just in, say it again.
I have a question. How do
Go
you
ahead.
get math symbols like radicals and stuff in your thing that you're creating? Because I can see you can do a math equation, but how do you get the actual math symbols?
Some of them are the ones that you just type in. If you type in like ABS something, it'll automatically do an absolute value. If you type SQRT and something, it'll automatically put in the symbol for square root.
Right. Yep. Some of that there are like on the, when you have the graph out, there's like a little keypad, that little pop-up keypad, then you can adjust. Same thing like with pi and tangent and infinity, and if you the integral symbols, all of those are available in some form or another, like some sort of a pop-up keyboard, or there are you can type words too. Like if you needed the symbol for infinity for some reason, you can type the word infinity and it should automatically change, especially in graphing mode, it'll do that.
Right. Okay, that should have given me square root x there. It did not. So I'd have to play around with that some and see why that's not doing it, but that's what it's supposed to do.
It worked in my, it worked for the square root, the SQRT, but it didn't work
Right.
when I put radical. So is there, like Luella's asking, and I was gonna ask the same question, is there a cheat sheet for these?
There could be. There could be.
Yeah.
I haven't searched for it, but there could be.
Right. And the other thing to do is just jump in on YouTube or Google or whatever and just say, how do I do a radical in Desmos?
Yep.
Or go to the learn.desmos.com. That's where you're getting the information straight from the Desmos creators.
Yeah. There's a lot of resources out there for showing it. Sometimes that's what I have to do. It's like, okay, here's what I want to do. How do I do it?
Right.
And I'll search for it and you go, oh, okay, that's how I do it. That's the steps that I follow. So
if we do learn.desmos.com, okay, and we'll just get that.
What do you want to learn about?
Abby put a link in the chat box that has the cheat sheet. Keyboard
excellent.
shortcut.
Keyboard shortcut. Okay, that's great.
Yep.
So.
Yeah.
Yeah, and some of those will only work like in the calculator or in the coding. They won't necessarily work in the description or the instructional part of an activity. But I noticed that on there there's a when you have those text boxes, there is looked like there was a little radical symbol on there with an empty box in it. Maybe that's where you would click on. There's a lot of stuff that we're still learning too. So
There's what Abby just threw in there, that keyboard shortcuts. So learn.desmos.com/keyboard shortcuts. So let's see what that says.
someone else was asking about other manipulative places, like as far as things like graphing and doing things like that and doing interactive activities. Another one that's very popular is called GeoGebra. It's a kind of a competitor to Desmos. There is a lot of great features with that one as well. A very different style of building your activities, but it is another one that's out there that's become very, very popular among math teachers, especially high school math teachers.
There's another one called ClassPad. And so if you go to classpad.net, that's actually a collaboration with Casio, one of the main competitors to Texas Instruments in the calculator divisions, and a teacher from Minnesota who said, you know what, I don't like what Desmos and GeoGebra are doing. I want to create my own. And so he went through and just created his own system, and it works pretty well too. So there's not like a, this is the end all be all, and this is the one you should definitely use. There's lots of them out there. Go around and find one and play around with it. For me personally, I really, really, really like GeoGebra for the geometry aspects of it. Like the geometry in GeoGebra is much better than the geometry in Desmos.
The feature, yeah, the manipulation
that
it can do 3D. It can do 3D graphing, which is what Desmos is not able to do 3D graphing.
Right. And it's very similar to the old Geometer Sketchpad, that we had years ago in the GeoGebra. And so it was something that I was already comfortable with. So I just used that one. So here, just like Abby had said, the learn.desmos keyboard shortcuts, and here's some links you can go to just see what some of those shortcuts are.
I will say though that for user friendliness, Desmos is much more user friendly than GeoGebra. GeoGebra involves a little bit more programming knowledge or detail. You have to kind of dig into the guts of what you want to build, unless you're taking something that's already been built. It does involve a lot more work as far as figuring out how to get something to do exactly what you want. Desmos seems to be a lot more user friendly in that respect.
The other thing, just to be sure that we get it in here before our time is up, when we had you go to the student.desmos.com and the activity number, when you create one of these activities in here, and I'm going to back out of this. Okay, there we go. When we go into here and, I've got the a.ced2 creation station, and I can edit the draft, and you can see down here that there's an activity session that I can assign to a class. In that activity session down here, it says MC5CDG, that code. Now, if I go in and edit the activity in any way, then the code for the activity that I already have is the old one. The activity codes do not update. So if you change your activity in any way, you need to go to assign and come up with a new single session code, or assign it to your classes if you're in something like Google Classroom or something like that. But if you get a single session code, then if you edit anything, you have to come up with a new single session code, because it'll take them back to the old one if you don't do a new one.
I have a question. As we are playing around with this and trying to create things, are you open to us emailing you with specific questions if we can't figure something out? And
absolutely fantastic.
Sure, definitely.
Yeah, no problems at all.
Thank you.
Yep, I think our contact was just shared in the chat.
Yep. And Gail just
slide as well.
Yeah, note that you can contact me, anytime if you want to ask questions. And one of the things we may run into is I'm going to say, I don't know, let's find out.
Let's figure it out.
There's
a lot of stuff that Andy and I were going, well, let's see what we can do with this.
Because I
We
had
built the plane as we flew it. Right?
I had used a lot of yeah, the plane as we get your background there. I had used a lot of Desmos just as a system, right? Just get the students into it, not have a activity pre-built, but just put them into it and let them start playing with it. And then I had used a lot of the activities that had already been built by somebody else.
Right.
This was one of the first times I really got in and started creating my own activity. And as we're going through and doing it, I'd be like, well, I want to do this. And Tom's like, hey, wait a minute. You just do that, right? If you want this to occur, this is where you go.
Right.
And so this activity that was created would have been a pretty decent activity if Tom had created it. It would have been a pretty decent activity if I had created it. But it was a much better activity when the two of us worked together.
Right.
Much, much, much better.
Yeah. And if any of you are familiar with just the calculator side of Desmos, it's very similar. I mean, you've already got
Yes.
a bunch of it. You've already understand a bunch of it already if you've been using the calculator. So the building of the sheets, the pages and the sheets are just the next step.
Yep.
Thank you
So-
so much.
Yeah, it's an
This
awesome
was-
resource.
Yeah. This session was awesome. So thank you both.